differentiation? Differentiation can be defined as the derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. When do we apply differentiation? Based on our topic, the derivative was used to find the maximum and minimum value of a function. After that, differentiation was applied when determining the increasing or decreasing of a function. It is also used when determining the distance of moving an object and the speed. What is applied maximum and minimum problem? The process of finding maximum or minimum value is called optimization. For example, companies often want to minimize production costs or maximize revenue. By GPS system, by shipping companies delivering package to our home, by financial companies, airline reservation system.
So, how to solve applied maximum and minimum problems? First step is we find the derivative. Second, we let the derivative equal to 0 and find the value of the variable. The third step is we use second derivative test. If second derivative is bigger than 0, it will become minimum value. If the second derivative is less than 0, it will become maximum value.
Problem 1. A farmer sells X lb of strawberries at a cost of Cx equals 10 minus 1 over 20x. The farmer wants to find what quantity of strawberries to sell in order to maximize his profit. First, explain why the profit function, the function the farmer needs to maximize, is Px equals xCx equals 10x minus 1 over 20x squared equals 1 over 20x times 200 minus x. Second, what quantity of strawberries should the farmer sell and what is their profit? Problem 1. To solve problem 1, question 1, we need to give explanation of the profit function. The profit function Px is derived as follows. First, revenue. The revenue is given by Rx equals to x times Cx, where Cx is cost function. Second is cost function. The cost per pound of strawberries is Cx equals to 10 minus 1 over 20x. So the revenue is Rx equals to x times 10 minus 1 over 20x, which the result will be 10x minus 1 over 20x squared. Therefore, the profit function Px is expressed as 1 over 20x times 200 minus x. So here's how to solve problem 1, question 2. To maximize the profit function Px, first we need to differentiate. We know that Px is equals to 1 over 20x times 200 minus x. Therefore, P prime x, we will get 1 over 20 times 200 minus 2x. But how do we get this? In order to get P prime x equals to 1 over 20 times 200 minus 2x, we need to use product rule. Therefore, we have to let u be x and v be 200 minus x. Why we are not using 1 over 20? In this case, 1 over 20 is a constant multiplier. So when differentiating px equals to 1 over 20x times 200 minus x, we treat 1 over 20 as a constant and apply the product rule to the rest of the function. Therefore, u prime is equals to 1 and v prime equals to negative 1. Then p prime x will be 1 over 20 times u prime v plus u v prime. Then we sub in everything into the equation, which is 1 times 200 minus x plus 200 plus x times negative 1. Then we will get 1 over 20. 200 minus x, and there we will get 1 over 20 times 200 minus 2x. So here's how we differentiate to get 1 over 20 times 200 minus 2x. Second step, we need to set p prime x equals to 0 to find critical point. So we know that p prime x is equals to 1 over 20 times 200 minus 2x. Therefore, we need to make 1 over 20 times 200 minus 2x equals to 0. Then we get 200 minus 2x equals to 0, and x is equals to 100. So for the third step, we need to verify x equals to 100 gives a maximum by checking the second derivative. We know that p prime x is 1 over 20 times 200 minus 2x. Therefore, to get p double prime x, we need to differentiate. So first, we need to multiply this and multiply this, which will get 10 minus 1 over 10x. Therefore, p double prime x, we will get negative 1 over 10. And since p double prime x is equals to negative 1 over 10, and since negative 1 over 10 is lesser than 0, therefore x equals to 100 is a maximum. So for the last step, we need to compute the maximum profit by substituting x equals to 100 into px, and we know that px is equals to 1 over 20x times 200 minus x. Therefore, p100 is equals to 1 over 20 times 100 times 200 minus 100, and then we will get 1 over 20 times 100 times 100, and the final one we will get 500. So for the final answers for this question, first, the quantity of strawberries to sell is 100 lbs. Why? Because X is the quantity of strawberries and X we get just now is 100. And second is maximum profit, which the answer will be $500. So here's how to solve this question.
Okay, so we have now come to the conclusion part. So when we are received with the question, we first have to try to relate the concept of application of differentiation to the question, and we analyze the question and accumulate as many as important information from the question that we can get. So next, we find the derivative and let the derivative equal to 0 to find the values of variables. And then we use the second derivative to determine whether it is maximum or minimum value. So here are some tips. If the second derivative is bigger than 0, the value will be minimum. If the second derivative is less than 0, the value will be maximum. So the last thing is we have to substitute the values into the equation and we solve the equation. That's all.